It's January 15, 2025, and I am Gary Berg-Cross. Ken, who normally hosts these things and kicks them off, Ken Baskowski, whose name you see on the slide, is traveling today. So I'm going to try to do some of the hosting material for him and also make my presentations as well as introduce the other speakers. So with that, let me start here on the slide. So this turns out to be our 20th Ontology Summit. We started in 2006. We started with an Ontology Summit, which was about upper-level ontologies, but it certainly involved the related question of what is an ontology, and the idea that discussed then and since is that it's more than just a theory. It's a special type of conceptualization. And of course, it should be valid and correct. And to do that, it requires ontological engineering, analysis, conceptualization, and formalization. And the idea is that, of course, there's a relationship to all of those things I've mentioned, as well as to the idea of theory and semantics and so forth. And so this summit is going to try to explore in its 20th year some of those issues and relationships. And as part of that, we have organized, and I have organized in particular, track one with a keynote address by Nicola, who is already online. And his working title is Ontologies as Specifications of Conceptualizations, with the idea of going into correctness of them, precision, and accuracy. Continuing on with track one, I will describe the other four people presenting as part of that track. And at the end of that, there will be a transition from track one to track two by Ken, who's going to talk about what is a theory. Following that, we get into track two, which will be, Alex is here, and he'll have some slides on this later on. His track is entitled Theoretical Knowledge and Reality. We get into some philosophical issues, get into the nature of theoretical knowledge and what's normative there. And of course, we have many definitions in science and in ontologies. And so there is issues around adequate definitions from different points of view for ontologies. Following the end of track two, which takes us about 2 months of activity, we'll get into what we call a first synthesis session, which is sort of trying to digest what we've already heard and with an idea of eventually producing a communique about this. So roughly halfway through, we will have a discussion about what we think are some of the key points and issues and so forth. Continuing on with the summit, we have track three, and Mike is here, who will present some details on this, ideas on this track, which is called right now From Reality to Data. We'll get into some of the issues about truth-making, perception, situational awareness is a big issue there. Quality of ontologies runs throughout, I think, the entire summit. What do we mean by a quality ontology, a quality theory? And then there are perhaps issues of visualization. And we finish with track four, and Ravi, who's on, again, and showed his slides briefly there. We'll have a track on ontologies and data. Obviously, there's lots of data that goes into knowledge graphs, which has been one of our topics. Ontologies relate to a large amount of instances of data, and there are experiences that may be relevant there, and other topics that he may explore besides that, dealing with things like reasoning and trade-offs that might be considered. Following track four, we'll have a second synthesis session as a preparation for our communique. Okay, and so let me stop sharing that and see if I can share my slides for track one. Let's see, here we are. Okay, hopefully that's all visible to people. Is that visible enough for people? I don't have it on slide mode. I can turn it on. Let me actually stop and go back to the slides and make it in slide mode. Slide share, I mean, okay. And well,
you go
okay.
Into the well,
so okay, so hopefully you can see all of this now. So I thought I'd start track one with bridging back to our first Ontology Summit in 2006. And what was going on there, many of the major people in charge of ontologies, developing ontologies, key technologies, and so forth, participated in that summit, which was called, it was related to upper level ontologies. But the discussion was much broader than just that. You see on here a few bullets on some of the things that the communique talked about, which is what people agreed on at that time. How do we achieve modularity and handle incompatibilities between different ontologies that are being created? Of course, there were incompatibilities even with the upper level or foundational ontologies then and since. There's the idea of how do we map between these relevant ontologies, particularly the upper level ontologies. There were discussions about common languages, barriers to agreement, assumptions on the ontologies, important dimensions such as competence and qualities of the ontologies and so forth. And so you'll notice that a lot of these are very relevant to issues in ontologies still. Okay, so my second slide here is some of the premises that I believe are relevant for track one. At least I went into some of my thinking. And in particular, it's the idea of the centrality of conceptualizing and analyzing as we ontologize to represent reality. So the past summits, I think, help us understand that prior to formalization, the axiomization, we need to have a clarifying quality process that precedes the formalization and is an essential part of ontological engineering. So some of the premises I have detailed down here. Formalization may be less important than a proper use of conceptualization and commitments to conceptualizations, since that drives the downstream products. Another premise is to avoid limiting mistakes. We need to take systematic semantic analysis seriously, and in order to models to be shared, integrated beyond formal semantics, conceptual models need to be explained in terms of their ontological commitments to the world process and the real world, and explanations about real world semantics. And of course, this is after some of our keynotes and following speakers of Nicola and Giancarlo. So here it lays out the speakers for track one, starting with a keynote by Nicola. I mentioned his topic before. That's going to be next Wednesday on January 22nd. A week later, again at the same time at noon Eastern Standard Time, Giancarlo is going to be talking about, from the article that he and Nicola share on semantics ontology and the role of explanation in understanding that. On a week after that, February 5th, Michael Gruninger, who's also here, will talk about the heirs of Hilbert's sixth problem, which is about the mathematical treatments of the axioms of physics. It's sort of interesting the way the track has unfolded. The first two speakers are interested in conceptual semantics in particular, and Michael and Barry Smith, who is our fourth speaker, are interested in some of the axiomization issues about these things. So Barry will be on February 5th, 12th. And I believe all of those will provide a good foundation for the subsequent tracks and the summit as a whole. So I wanted to have a slide or two on some of the things I think might be part of our speakers. And some of our speakers are here, so I apologize if I've misrepresented these in some way. But this slide uses a portion of Nicola's diagrams on conceptualization and intentions in building ontologies. So we have ontologies here on the lower right of the diagram. What's the process by which you get there? Well, as I've sort of constructed it here using portions of what he has in other slides, it starts on the upper left with some agent observing some portion of reality. Here I have someone looking out of a cave and seeing a portion of reality. Well, you might understand that reference. then I sort of like to think about the observing agents thinking through what they're seeing and doing some situation analysis. What is this about? And that leads us over to Nicola's diagram on conceptualization, big C. That results from one or more observers, maybe in conversation, conceptualizing some aspect of reality. And then the very important part is the I part, which is you have an intention to commit to a certain conceptualization. And that brings us lower down in the diagram where we select a language that can represent some parts of that conceptualization. In this case, we have this very large red thing, and we have a few other colored things that are one within the other. They need not be that way, as I would understand it. They can be overlapping in some way, and so that might be some parts that are excluded from things, like you might not be able to represent an important commitment in a particular language. In any event, as the diagram indicates, often what you intend is not exactly what has been represented in the ontology. It may be more or less, and this would be part of our judgment of what is the quality of an ontology. The other thing I would say about this from my own point of view is that this diagram, replacing a few things, is also the process of science, which is particularly of interest in this summit. So if I just want to sort of come out with a scientific theory at the end, I again have some conceptualization, and I also have some commitment to that conceptualization, and I might use some mathematical language other than logic, such as differential equations, to represent that understanding, conceptualization of reality and the outcomes of theory. And so that, I think that sort of segues a little bit into, will eventually into some of the other things that we talked about in this summit. I wanted to spend a little bit of time on what I think of as conceptual or ontological analysis. Others may have a different view of that, but I think this is a start. So when I think of ontological analysis, I think of a process to precisely, or at least as just possible, precisely identify, break down, and relate entities that are intended to constitute an ontology by studying and understanding the conceptual content of people's minds, of people's assumptions in their mind about it as such. And this is independent of their representation, which is subsequent again to the conceptualization, can be of any form, and some forms might be better than others. But this is a starting point from my point of view in terms of what goes into ontological analysis. With that, I now have a diagram on that combined session 1 and 2 because Nicola and Giancarlo work very extensively together and have produced an article together. And some of the central development of that research and thought that's represented in their articles, a pragmatic notion of explanation, which they term ontological unpacking. And that tool, that conceptual tool, can be used to explain symbolic domain descriptions, of which we have many, knowledge graphs, logical specifications like ontologies, but also conceptual models. So the idea is that it works by revealing one's ontological commitments in terms of what are the anchors that are called truth makers by them, the entities in their ontologies that are responsible for the truth and description. And I note at the bottom that just logical representation allows us to preserve the truth made by truth makers. They don't determine it to start with, but they preserve it. Okay, so what are some examples of some of the things you might find from ontological analysis? And this is a list from an earlier summit, theories of parts, unity and plurality, and many of these things Nicola sort of espoused early on, essence and identity, theories of dependence, going down to roles, and maybe theories of space and time. I pose a question at the bottom that might be answered or discussed, at least in part, later in the summit, which is whether this can be the basis for a meta language that can be used to make meaningful propositions and statements. And so perhaps we'll hear more about that. Before I go to the next speaker, Michael Gruninger, I just wanted to, he's one of the authors of works on hydrology, ontologies. Here's a small diagram which makes some commitments, as it were, to what are the parts of a river system, which we recognize. And there's more about these type of things in the work of Boyan, Broderick, Thorsten, and Michael on things like that. Boyan in particular has taken the opportunity to develop a geoscience ontology reference. So this is a different science than physics, but related. And this is just a small example of what trying to build a reference of the essential entities, the truth makers, as it were, in part, that are involved here, centered around the idea of a rock sample. We get the idea that it's essentially comes from a body, a rock body, and that the rock sample is the object of interest, and we know something about its constituencies, such as shale. And because this is a scientific investigation, we know something about where it was, what event happened as part of the sampling, and so forth. So this gives us a little bit of an idea about some of these truth-making ideas that come out of ontological analysis. But what about physics rather than just hydrology and things of that nature? We've had some discussions in this past summits about physics, particularly naive physics, and we've invited Patrick Hayes, who might be a speaker in the future, who might be sort of updating some of his thoughts on this and maybe responding to other people's thoughts, like Barry Smith's discussion of the nature of physics and the semantics of it. So we know back in the 78 and a little bit on, he was proposing this idea of naive physics development with a dense axiomatic form of understanding of this, but it's mostly about, again, common sense notions of physics. That's what naive is about, as opposed to a very elaborate, based on current science understanding of physics. Still, many of the concepts that he has listed down here and emphasizing seem relevant. So it's an interesting contrast to what we may hear from Barry when he talks about quantum theory, for example. And here's another example from a prior summit. We had Ernie Davis as a speaker at one point, and we tried to ask Ernie some ideas about, he had reviewed naive physics. He also had some ideas about microtheories from Psych. And this diagram gets at some of the ideas about how to conceptualize naive physics with some broad ideas at the bottom, such as solid object kinematics that go into liquids and solids on the left and rigid objects on the right, and it get increasingly constrained as we go up. So you can imagine the axioms starting at the bottom and adding more axioms to constrain this model. So that was part of the idea. With that, let me turn briefly to Michael Gruninger's track or session, which is called The Heirs of Hilbert's Sixth Problem. And as Michael explains, the sixth problem posed by Hilbert has never been adequately addressed in his opinion. And that problem was the idea of how to treat how to mathematically treat axioms of physics. And as he says here, his talk will explore the ways in which ontologies are the axiomatic theories that are required to solve that problem, the sixth problem of Hilbert. His talk will also consider how the methodology for evaluating scientific theories can be applied to the problem of empirical evaluations of ontologies, which I think is a good lead into our final session and my final slide, which is more about physical theories of mathematical entities that will be presented by Barry Smith. We have on this slide an article that he has published along with Jobst on ontologies of common sense physics and mathematics. The starting point for them was to answer the question of why is there no convincing ontology of physics? And part of their argument is that we help ourselves by using entities from mathematics, such as are used in not only in physics, but ontologies. which we fully understand semantically, he says ontologically, but we have no ontology of the reality of modern physics. We have only what we can assert mathematically. So I think this will be an interesting discussion based on a follow-up onto what our prior presenters will have. And so I look forward to actually the next 4 weeks of these as part of track 1. And with that, let me stop sharing and let me turn it over to Alex, who will introduce his second track and some of the ideas, and that will go into that. And I think there'll be plenty of time for us to have questions and answers after all of the sessions have been and tracks have been presented.
Sorry, my sound
Yeah.
was closed.
Now we can hear you,
And
but
can
little
you see my
louder.
slides? Can you see my slides?
Yes.
Yeah, great. Then we have 3 sessions, and not one, but first session is about philosophical, let me say, formalization, because we have formalization of philosophical doctrines and theories. Then, as Gary told on his words, we begin from phenomenology to the doctrine of being and of existence, and then theoretical knowledge. This is what we know as common sense knowledge if we do not formalize it, but if we can invite somebody from side, it would be great. So terminology give us of common knowledge, give us possibility to describe phenomenon without having its theory. It's absolutely true for new phenomena. It's very interesting position when we are talking about theory of one entity or another entity.
Hello, we lost you.
We need system. It's now better. Oh, sorry, something. Can you hear me?
Yes, now.
Okay. Then we need system of terms for describing the being, phenomenon, and other things and this is what we have in top-level ontologies. Then we have formalization in this area. Moreover, for example, just example of laboratory, International Laboratory for Logic, Linguistic, and Formal Philosophy, when we have this kind of studies and projects. And for example, we have 2 very powerful projects. One is of Edward Zalta, Principial Logic of Metaphysica. It's approximately 1,500 pages of formal metaphysics. And Urs Schreiber has Science of Logic of Hegel, formalized, let's say, partially. Then even on this very, let's say, abstract level, we have formalization. Okay, and with primary terms, and this is why we do not have unified theory of physics or ecology or nature, is that primary terms of theory are recognized by people's mind. We do not have formal definition for primary terms. Then we have a lot of theories based on one or another primary terms. And there is very important thing known from math logic and for example, from geometry, then we may have many theories for one and the same part of, let's say, nature. For example, for Euclidean figures and Euclidean space. Now, the last philosophical point is, how is knowledge possible? Knowledge is possible because we usually have very simple, it's in brackets or in double quotes, initial parts of our entities. Our entities around us is giant clusters of atomic nucleus, and the charge of this nucleus is only from 1 to 190. And this nucleus is neutralized by electrons and exchanging photons. And other important feature is that the mind can operate with visual images directly. And this is what we do not have directly and very precise. We do not have this yet from Gen AI. So, next session is about theoretical knowledge itself. Here, the main point is that we need to study how this knowledge exists in the society, in which forms. We need not to invent, for example, it's very important, we need not to invent new theories. We should find theories we have, and we formalize these particular theories we have. We should not issue our own terms. It's dangerous, because experts can reject our maybe very good terms. And what is the reason to keep it? But this is a topic of discussion. So we need normative forms of theoretical knowledge in different sciences and technologies. We need exactly to show and describe where this theoretical knowledge is stored. It's very important. We begin from this. We find some theory, and then we formalize this theory. Then we have huge system of sciences. Hegel began to describe system of sciences. Now it's impossible, let's say, for one person. So the corpus of document is a very important thing. Now, in our web interface era, not interface, era, we can concentrate knowledge in a way not possible before, because we can put all theoretical knowledge in one particular kept by experts place. We have this more or less right now, and ontology is one of the new way to keep theoretical knowledge, because it's more than dictionary. So, and it has thousands of terms sometimes. So, and our activity itself is actually, let me say, a little bit simple, because we just take theoretical texts and rewrite them or translate them to one or another mathematical logic language. Okay. This is about theoretical knowledge. So,
Yes, Alex. Next slide.
oh yes, I pushed wrong button. The next slide is small bullets, but this is most important maybe when we are discussing structure of theory, because the brilliant of theory is definition. Actually, structure of definition is more or less complex, and we have articles about by Smith and C.L. Seppel and others about this kind of problem we have with definitions. And we need to discuss logical, and I put it syntactic analysis, but this is analysis of the whole structure when we have a lot of unneeded things inside of definition. Then we can translate this definition automatically to formal language because it just there are a lot of information we need not. And we will see examples of definitions in current theoretical texts when we found this theoretical text itself. Okay, this is for track 2.
Cool. Thanks, Alex. So I guess track 3 is next. And oh, it wanted me to do a thing. Let's try that again. Share screen. Hurrah. So I wanted to do a complicated thing when there was already somebody sharing and I'm not even a moderator. So track 3 is going to be about from reality to data. I'll just pop this into presentation mode. Hopefully it won't truncate at the sides or anything. So you should see the full screen now.
Yes.
Cool. So our overview, as you saw in Gary's introductory slides, we're covering stuff like truth makers, perception, situational awareness, also quality control. That cuts across all ontologies, as Gary mentioned, but what's the quality control angle here? And how do we deal with things like data verbalization and visualization and so on? So a bit of a grab bag, but you heard a lot of theoretical stuff, the theoretical underpinnings of how ontologies represent the world or our different conceptualizations of the world. How do we put that to work now in the realm of data? How do we get from ontology to data? So I'm going to set the scene here first with a couple of thoughts. You probably saw there was a thread on the Ontolog mailing list, which is a sister mailing list to this Ontology Summit. So you've probably mostly seen it. Is an ontology a type of data model? And a surprising number of people say, yes, an ontology is a kind of data model. Well, everything you've just heard in the last couple of tracks has had nothing to do with data models, and rightly so. So is an ontology a kind of data model? Well, maybe some ontologies are and some aren't. Then how do we relate those? And this is where the notion of truth makers comes in. You saw that mentioned in Giancarlo Guizzardi's talk overview. He'll be talking and introducing the notion of truth makers. We'll take a look at some practical aspects of that. And from that, we get to what are the kinds of ontology, the ontologies that are kinds of data models and the ontologies that are not. How do we fit them together in an engineering environment, provide that kind of engineering integrity that allows you to have not only quality control of your ontologies, but quality control of your end-to-end engineering. So what's the truth maker? Let's look at an example. Always best to start with an example. If we were to say of any autonomous entity that it has some legal capacity, and that legal capacity is the class of things that are a kind of legal capacity, what does it mean to be a legal person? In your basic everyday definition, probably fine-tuned a little bit from one jurisdiction to another, but your basic common notion of a legal person is that which is able to incur debt and be sued at law. In other words, it has the capacity for legal liability and the capacity to be a debtor. So when you want to know the meaning of a thing, and we want to use the logic of ontologies such as description logic or first order logic or common logic, rather than relying on words, what tends to happen in business is a lot of organizations use ontologies for the data side and then go back to words and glossaries and dictionaries and stuff when it comes to defining the real world business meaning of things. But we can do that with ontology. It's kind of what ontology is. So what does it mean to be a legal person is to have these legal capacities. And here I'm showing them using what are basic restrictions or refinements of that has legal capacity property. Great. Now we know what it means to be a legal person. it's true of a legal person that they may incur debt or be sued at law. These are the truth makers. These are the things of which, if it's true of something, that something is a member of the class of things that are a legal person. So that's very simple what we mean by truth makers. Now, when you look at a data ontology, people often go straight into the data and start putting in bits of data that roughly correspond to something. We can do that in a more principled way. If we look at the truth makers for legal personhood, and we're looking for data, in fact, there'll be different kinds of data in place corresponding to those truth makers. So what we're looking for is, if you're doing an ontology that's processing data, you don't have access to the truth. You don't have things like legal capacities and capabilities. What you have is data. So we split legal person into individuals and organizations. So a legally registered institution, like a registered company, for example, you have some legal form that could be a limited company, could be public limited company, even a limited partnership or something. It's registered in some jurisdiction, and in that jurisdiction is issued some registration number, and it also has a registered address and so on. When you see this stuff in data, it reliably corresponds to the fact of those truth makers in the legal reality of types of legal capacity or capability. Now, you can still create data for those as well. In fact, you can use a reasoner to populate such data. But what we're looking at here is what we call the data surrogates for those truth makers. What properties expressed in data reliably indicate the presence of the truth makers in the real world in which something has its real definition. So this allows us to take a very old-fashioned, and rightly so, engineering approach to things. Now, this isn't necessarily waterfall, but this is a separation of concerns, regardless of what sequence you do the development work in. You have a concept model or computationally independent model, which describes the business problem independently of any design or solution. And then, particularly with data, you have logical and physical models. So a logical design, there's a design that could be instantiated or implemented in a number of different physical platforms, different programming languages, different data formats or whatever, as the schemas for the actual data. So simple model-driven development creates this separation of concerns between business and technology. A lot of people out there think that you can take a logical data model, cross out all the complicated bits, show it to the business, and that's your what's often called a conceptual model. That's why we start using a concept model instead of a conceptual model, because the true concept model is not an abstraction from the design. It's done before the design. It is a concrete representation of the reality, or at least of some abstraction of reality, since all models embody some kind of abstraction. But it's totally in the business world, the business language, has nothing to do with the design. Now, when we take ontologies, this is where people often get confused between different types of ontology, or they assume that what they call an ontology is the only kind of thing that can possibly be an ontology. So let's take a simple example using description logic here. The same thing would apply if you're using first order logic or common logic or any of the other logics. But you'll see in a moment why we use description logic, because you can serialize that in OWL. So you have a description logic model which represents things in the world, or strictly our conceptualizations or abstractions of what we believe exists in the world, in this business world, things like those legal capacities. Even if you create an OWL model of that, at this point, it's still an OWL model representing those real things. So think of it in terms of a kind of switch here. There's almost a third rail thing. Your OWL model is not a good use of OWL. It's not what most people use OWL for, but it can be a way of serializing your description logic model. It will still represent things in the world, as long as you're not using RDF instance data. That's where, as soon as you have instance data, that exact same model is now no longer a model of things in the world. Its referent is now the data. So every model is a model of something. Every element in the model, it either represents real things, or it represents object-oriented constructions, or it represents relational database concepts, or it represents RDF data concepts. Any model represents something, regardless of what its language is. Those are distinct and separate. So as soon as we create an RDF set of instance data from an OWL model, we've hit the third rail. Now, this isn't going to be very useful OWL ontology. What you've got effectively is a kind of conceptual data ontology. It's now a model you can stand up in data in which everything corresponds to something in the world. But it's not really very useful because you need data types. So you need to make typing decisions, design decisions. Is this a number? Is it a string? Is it a float? And for most things, as we saw, there is no such data as legal capacity. There are data surrogates, such as company registration numbers. So as part of the design of a good conceptual data ontology, this is an ontology you can use right across the organization as a schema for your RDF instance data or your knowledge graph. You have typing decisions and data surrogates. You have something that's living at this logical level. It's a technical design now. And in fact, for most individual applications, people like to say, I need a use case before I create an ontology. Well, to have a use case is to be an application. So really what they're producing is these application ontologies down here. You can also take any existing data model or XML schema and create an RDF representation of that as a data ontology, very useful for mapping. But these are all in the logical or design domain with your instances there in RDF instance data. So that gives us this whole kind of catalog of kinds of ontologies. So we're going to explore how you use these different kinds of ontologies, what they're for, and so on. Another thing we're going to look at is situational awareness, which involves perceiving, analyzing, and responding to situations. There's examples in law enforcement and defense and air traffic control, but also in manufacturing, physical digital twins and so on, anywhere where you've got some feedback between the real world and the stuff that's in the model of the things in that world. And again, some of those models will be as a conceptual data model, some will be specific extracts from that to provide different kinds of RDF schema type data models. So if you look at a multi-domain operation here, cyberspace, air, land, sea, whether it's military, disaster recovery, emergency response, all those kind of scenarios. So how we're going to do this, we got three sessions on the track, and you saw we got more than 3 bullet points there. This is going to be curated by a little stealth community that's been going for some time now called the Semantic Shed, which is all about focusing on the distinction between conceptual or concept or explanatory ontologies and data ontologies and how you relate those, all the stuff I just talked about. We've got a number of things that folks have been working on. We'll reach out to other speakers as well. We're always interested to hear what people have. We'll be looking at the notion of this concept or explanatory ontology and some insights in what's the difference between being an instance of something in an RDF data ontology versus being an instantiation or instance of something in the real world in an explanatory ontology, the sort of direction of travel there. We've been looking at different ways of representing ontologies in controlled natural language and visualization techniques and so on. One of our members has published some work on narrative, rhetoric, and event theory, what's being reported or discussed about the world, so that will fit into the situation awareness stuff, I think. And we're continuing to explore foundational considerations, mainly with reference to OntoUML, but also BFO and others, and how we ground the meanings of things, picking up some of the points in some of the earlier sessions in terms of the grounding in semantics with truth makers and the axiomatization of that, the axiomatic grounding with top-level ontology, partitioning, and so on. So we've only got 3 sessions. The dates aren't explicitly published, but if you add them up, it's sort of late March through early April. We haven't got the precise session plan yet, but looking at those bullets we have, we're going to look at some stuff about truth makers, expanding what I just talked about with data surrogates, fingerprints, creating data shims for different ontology typing schemes and data typing schemes, how you trace those back. We'll look at perceptions, that covers qualia, value spaces, again, relating a value space to a typing scheme, particularly in digital twins, where you have measures and quantities and so on. Situational awareness, so again, real-time updating and digital twins, narrative and event theory, and multiple domain awareness that we just saw, and how quality assurance cuts through all of that using this model-driven development, how we get the traceability from your data surrogates back to your truth makers, and how that helps us with the classical QA activities of validation and verification. And we'll look at some of the data visualization techniques and so on. Not one-to-one, since we have 3 sessions, so some of these will be combined either as separate presentations in one session or combining some of these topics like the value spaces and truth makers and so on. So that's us. On to track 4. I'll stop sharing.
Okay. Ready?
Yep. It's on your.
I do hope we have a little bit of time at the end to discuss some of these things.
I'm going to only take 2 or 3 minutes because I realize that we are late. We are not giving 15 minutes for our speakers, our attendees to make their comments. So therefore, it is important that I keep it brief. Mine is anyway, the session that I am dealing with as chair of the track 4 is dealing with ontology and data, and lot of preliminaries for that are being covered in tracks 1, 2, and 3. For example, ideas relating to science, ideas relating to theories, ideas relating to a practical way of handling ontologies like reality and data, as Mike described, other two speakers described before me. Uh, the the part that I deal with are only two of these things. One is ontology and mathematical theory. And here are some references I'm giving. And I request everyone who is participating or is connected to other people with whom the participants communicate to suggest speakers for each of these tracks. The track 1 is more or less taken, but for other tracks, we are open and are listing uh, leading speakers in the field whom we would all like to hear. So Quine was the name that came on topmost in ontology and mathematical theory, and then people, Shapiro and others have worked a lot, and Frege and so on. But what I want to say that John Soa, our trustee, our colleague on the forum, has been telling a lot about this. So we will get to hear from him in one of the sessions. The second example was large amounts of instance data. So A box, T box kind of classification, and these are a couple of papers that are on top dealing with large instances of data. Of course, data, when they are represented in RDBMSs or relational form, as Mike described, the cascading, conceptual, physical, logical, physical, and implemented data models, the elements of enterprise architecture are always very large amounts of data. So are also LLMs and knowledge graphs. So all these how do these relate to ontologies would be some of the topics in this track. The last one, which is dearest to my heart, which I was able to squeeze, is really what is it that has caused physics and chemistry, and of course, obliquely biology, because the chemistry Nobel was due to bio type of work. But how did the physics Nobel and the chemistry Nobel last year, went to AI people rather than the scientists, the traditional scientists who work in lab or theory? So there are these 3 bullet points: data storage, pattern retrieval, and backpropagation. These go and take us beyond standard model in discovering new particles and resonances and theories about that and how ontologies are related to these. I'm now going to stop at this, but I have 2 questions. One, it was said that there is no ontology of at least bulk nature. In Sanskrit language, there are 5 elements that are basic mega elements, One of them could be sky, ether, or vacuum, whatever way you translate from Sanskrit. And the other could be water, earth, fire, and so on. So there are relational ships and details of those ontologies. It's just as a point I wanted to mention. Thank you. Please proceed with questions and answers, Gary. We will
Yes.
request anybody can either speak or raise their hands or do both.
Yes. I first want to ask, since we have two of our speakers from track one, if there's any clarifications, expansions that they want to make about what they will be talking about in the coming weeks. So Nicola and Michael, I would, welcome any things you want to say to essentially clarify things and maybe also motivate people to come to listen to what you're going to be talking about.
Meantime, I request you, Gary, to take off my presentation. I don't know how to do it.
Okay. I'll try.
Well, Michael here. Yeah, so I think this, really looking forward to this summit. I think the mix of ideas is quite interesting. It's a nice new recombination of a lot of the challenges that we've been facing over the past 20 years, as you say, with these different ontology summits. So it's an interesting opportunity for doing a new kind of synthesis. And I think one of the things that I guess I'll be talking about would be we've seen that word theory, right? And to be able to kind of look at that, and I think the question is, how do we design such theories, which we're calling ontologies, in terms of the physics and the relationship to qualitative physics, so like that sort of thread that was picked up, Gary, in your overview. And I think the other key idea, we want to really see is kind of the evaluation design. So, a fresh look at another earlier summit, which was the ontology life cycle, right? So, are there just some new perspectives that we can get by recombining some of these new ideas of how ontologies and science are related to each other in innovative ways? So I'm really looking forward to the summit as a whole. You guys picked a great topic, a great theme.
Thank you. And I think my view of what track one and the keynote will allow us, as well as Ken's later talk, is to sort of prepare us in a more deliberate way for the tracks that are going to follow. So we have the right types of thinking about it, although there'll be alternative thoughts about it, but I think that will enrich the later tracks also. Nicola, you have anything to say?
Yeah, I'm very excited of the idea of discussing about the link between ontologies and scientific theories and so on. This sounds really interesting indeed. And concerning my talk, well, there will be not much new. I will basically, recap what my own ideas on what an ontology is for the general public. Maybe stressing a little bit this criteria for assessing the quality of an ontology. Okay. One thing which is not very clear to me after Mike Bennett's talk is the link in which ways ontologies can be linked to data and so on. This stuff is not totally clear to me. I will have a look at, maybe we can discuss together with Mike about that.
That would be nice. There's a lot to unpack. I didn't want to overload the slides, but I'd love to talk to you more as we unpack that, because it's about that engineering end-to-end integrity, not losing the quality of the explanatory ontology at the top.
Well, okay. I'm looking forward to that.
Nicola, we are looking really very excited to have you give us the overview in our first inaugural session.
Okay.
We are very excited. We are all waiting and anxious next week.
I'm very much honored of that.
I would just add that I tried to convince people to include the slide that I used in part about this process that leads to an ontology and people on the committee weren't sure exactly if they understood it the same way. So I think even though this has been done before, I think we
Yeah,
still
yeah.
need to do some of these things and discuss them as a community.
Yes, yeah, it makes sense. Sure.
Any other comments or questions?